This is the solution video for question 12, paper 2 of the TMUA 2020 exam. So the question here, it's about a statement that we're giving here, and we're given a bunch of options, and we want to figure out which one of these options will correctly complete this statement. So the statement is, given that a is less than b, and f of x is positive for all x, with x between a and b, then the trapezium rule produces an overestimate for the interval of f of x from a to b when what holds. So essentially we need to complete this with either a, b, c, d, e, or f. Okay, so the conditions are labeled as if, are phrased in terms of if and only if statements, and if and only if statements. So recall what that means. So basically, only if means that a condition is necessary. So for example, in B, if we're saying only if f dash of x is 0, it means that f dash of x bigger than 0 is a necessary condition. And if we only have an if statement, then it means that that condition is sufficient. So for example, in A, what this is saying is that f dash of x being bigger than 0 is a sufficient condition for this thing to hold. So we have to figure out which condition is necessary and which condition is sufficient. So let's first think about whether any condition on the derivative of x is actually necessary. So if we're trying to say that that there is no condition on f of x that's on f prime of x that's necessary, then what we need to show is that there is a function f of x such that this thing here holds, so we get an overestimate with the trapezium rule, but where the gradient changes. So one thing we could consider is this graph of y equals x squared plus 1. So we can see this graph is positive, so it does satisfy the condition here. And if we apply the trapezium rule, then we are going to get an overestimate, because no matter where we do it, we're always going to our little trapezium is always going to lie above the curve. But we can see here that the gradient of our function is changing from being negative to being positive. So that means that there is no restriction on what the sign of the derivative should be in order for this to be true. So in other words, all the statements that have only if f prime is bigger than 0 or f prime is less than 0, so only if statements on the derivatives, are not true. So this allows us to eliminate options B, C, E, and F, because B, C, E, and F all have only if statements applied to the derivative. So as we said, B, C, E, F are not correct. So now let's examine, so that only leaves us, with option A or option D. So let's look at option A. So we want then, if we're looking for a counterexample, we want a function f of x where the derivative is positive, but where the second derivative is negative. So we can pick a negative quadratic then. So in particular, let's look at this counterexample. So we're going to let a to be minus 1 and b to be 0, and we're going to let f of x to be 1 minus x squared. Then the derivative of f is minus 2x, which is positive when x is in the range of minus 1 to 0. And the second derivative is going to be negative because we have a negative quadratic anyway. Now, if we look at the graph here, then if we do the trapezium rule with one trapezium, so it's going to be this triangle, then we're getting an underestimate. So if this is true, so provided that statement 1 is true, then we found an example where statement 1 is true, but the statement that we need is not actually true. So that means that A is not, so this condition here and this condition here are not sufficient, therefore A is not correct. So that only leaves us with option D, and that is our answer.